The next thing I want to talk about is the frequency of compounding. Now, it's a pretty simple concept, but basically it comes down to one thing. Timing matters. So let's come across to Excel and illustrate this in as simple a way as we can. So let's say that I've got $100 and I'm going to invest it for 5 years. Okay, so $100 is my opening balance. Now my interest rate is 5%. Okay, so just like before, what happens in each year? In each year, some interest gets added. Okay, so the interest is that interest rate of 5% times the opening balance. So no surprises there, it's $5. I'm not taking any payments, I'm just letting it build up. So we're going to have a closing balance at the end of the first year, which is the opening balance plus the interest that we've earned. And that closing balance becomes the opening balance of the next year. Okay, again, in the second year, the interest is 5% of 105, so it's $5.25. And the balance, we just add the stuff up. Add it up, move it across. Okay, let's get rid of all those tens of cents and let's just make it to the closest cent. Okay, so simple situation. I've got a 5% rate of return on my bank account. I put aside $100 up front, ignore tax, ignore any stuff like that. If I just let it sit there, by the end of the 5 years, I'm going to have $127.63. Now, let's structure this slightly differently. So let's still make it 5 years, but instead of having interest paid once a year, we're going to have interest paid twice a year. So I'm going to have year 1, year 2, year 3, year 4, year 5. And in each year, we're going to have the first payment for the year and the second payment for the year. Oops, sorry. Okay. But we're going to do the calculations roughly the same way. Except there's something funny here about the way finance people talk about interest rates. So let's first describe quite clearly what was happening over here in the left example. This was 5% compounded annually. By compounded, it's compounded. Add it, smash it in, add it together. So it gets added to the basic amount. So that $5 doesn't get added to the 100 until the last day of the year. So you only start earning interest on that extra $5 when it's there from the last day of the first year. In other words, you only start earning interest on the full 105 in the second year. Now, what if we have the same rate, 5%, but we compound it semi-annually, which is just a fancy way of saying every 6 months. Okay. Now, there's something funny here about the way finance people use the terminology. When they say 5% compounded semi-annually, what they really mean is 2.5% paid every 6 months. Right? So when they say 5% per annum compounded semi-annually, they actually mean 2.5% per 6 months. Now, any of you with a mathematical background will realize that this doesn't really make sense, right? If it's 5% per year, then it should be the square root of 1.05 minus 1, which is not 2.5%. Okay, it's actually something different. Do not treat this mathematically. Treat this as an issue of terminology. This is the way finance people use language. When finance people use language and they say 5% per annum, compounded semi-annually, they really mean 2.5% compounded every 6 months. And you know that that's actually bigger than 5% per annum. Okay, and we're going to show that as we work through this example. Okay, so we're starting with the same amount we started with before, right, $100. The interest that we're adding is 2.5% every 6 months, 2.5% times that opening balance. And so the closing balance at the end of 6 months is $102.50. Now, notice the main difference here. What's happening is that $2.50 has been added on at the end of 6 months. So from month 7, you're not just earning interest on the $100, you're earning interest on the interest that's already been compounded, already been accumulated. So there's a little bit more earning power there, the more frequently interest is compounded. So we should see that we're actually going to end up with more than $127.63, I hope, if I've done the numbers right. Okay, balance at the beginning of the second 6-month period is the balance at the end of the first 6-month period. So interest we calculate the same way, right? 2.5% of that opening balance, $102.50. Okay, and look, already at the end of the first year, we've got $105.06 here, but we had $105 over there. Okay, so already it's a little bit different. Okay, so opening balance, let's copy this down. Let's get rid of all those crazy decimal points. Yes, we want to prove a point, but we don't want to go overboard. Okay. Compare where we're at the end of the Compare where we're at the end of the second year. A little bit ahead, a little bit more ahead. Okay. All right, anyway, to avoid boring you, let's push this all the way down. And where are we at the end? At the end, we've got $128.01. Whereas if we compounded annually, we have $127.63. All right, now this is a simple example. Low interest rates, low amount, short period of time. But imagine what the impact would be over a longer period of time. Imagine if you're talking about your superannuation savings. Somebody says to you, hey, do you want to put it in at the end of each year, or do you want to put it in every 2 weeks? I want to put it in every 2 weeks, because as soon as it's in there, I'm earning on that amount that's in there. I don't have to wait until it comes in at the end of the year. So frequency of compounding matters. And remember, when somebody tells you 5% per annum compounded semi-annually, they really mean 2.5% per 6 months. What is 2.5% per 6 months really annually? It's 1.025, that's 2.5%, squared. Take off 1. It's actually 5.06%. Let's just set that up as a percentage. So by compounding semi-annually, you're getting even more. And if you want to, work it out compounding quarterly. In fact, let's just quickly do one. This is going to be a bit of a pain. So 1, 2, 3, 4. I'll just do this really quickly, just to make the point. Okay, so equals that plus 1. Copy this down. I'm sure there's probably a quicker way of doing this, but the table makes sense and it's easy to see how we work through it. So again, we start with $100. What's it going to be? Well, it's going to be 5% divided by 4 if you're compounding every quarter. So it's 1.25%. Okay, so let's calculate the interest. The interest is 1.25% times that opening amount. The total is going to be the same. Formula, copy it down. Okay, let's just, at the end of the first year, $1.05.09. Here we have $1.05.06. Here we have $1.05. Okay, let's copy this all down and cut to the chase, see what we've got after 5 years. $128.20. What were we here? $128.01. Okay, already we're ahead by an extra 20 cents. Okay, so the more frequently you compound, the more you end up having. Okay, so that's all I wanted to say about frequency of compounding.